Hello everyone. So I had a couple of requests to share my RBD workflow recently, so I just decided to record this file walkthrough video. And for anyone that would like to pick up Houdini scene file and go through that, I posted it on Patreon and I'll put the link below in video description. Okay, let's dive into Houdini file. To start with, I just have a simple procedural building. I'm not going to go deep into that. It's just copied grids and some outer walls. I did have some more geometry there that I decided in the end not to use. I might use it for later. And yeah, I had character downloaded from Mixamo and yeah, just slowed down a bit, made it work for me. Maybe it's better to show like this. Yeah. So yeah, nothing crazy. So I'm just going to show you my approach to stuff like this. So basically what I like to do, I like to simplify things and then build up, add layers, right? Build up complexity. So first I'm gonna create this proxy version of my building, right? And then I'm gonna simulate that. So we're gonna get these big chunks. And this is basically going to drive everything. This is going to be our driver for all other sims. Basically because these are RBD packed objects, they're just a point that has information about the position and rotation through frames. So we can reuse that information to transform any other geometry. And I'm going to show you how to do that. So basically we're going to go from this simple stuff. Then we're going to transform our high-res fractured building, right? We're going to fracture our building. We're going to transform this stuff. And then we're going to keep adding, right? Then we're going to simulate these pieces in between to get some details, right? So we get this. As you can see, there's a lot of geometry. And then the next part will be after we get this, after we're happy with this sim, right? Then we're going to do some sim upres. So that's going to look like this. So we're going to add smaller pieces. You're going to see how that looks like this. So as you can see, we get a lot of smaller parts, which gives the sense of the scale, right? Like this versus this one. This already looks like the scale is right. But that's not the end. Of course, then we're going to add some just tiny point debris, you know. So that's going to be looking like this. This is just to fill up the space in between. So we have like we have a lot of stuff happening inside. So how do we go from here to here? Let me show you quickly. So as I said, we have this geometry, and I'm first thing I'm gonna do. Basically, I'm gonna create a proxy version of that, so just a bound. And here we have some padding. This is used later. I mean, maybe I went here a bit extreme. It doesn't need to be that big, but this is mostly useful for a fracture later. I'm going to show you why. So we're going to take this one and we're going to just fracture this box, right? So we're going to get something like this. So I just found a scatter C that works for me. You could do it in many other ways, instance some points there, whatever. For me, this was good enough. I thought this was okay. And I'm gonna leave these cuts. So we're gonna keep this geometry and we're gonna reuse it later for our fractures of high-res geometry. And then here, I'm just creating some piece ID attribute that I can have on points. So later I'm gonna use that to constrain pieces. And you will see I will do one more fracture on this. So basically, I just split these guys. And I do one more fracture, right? So we cut them here, here, here. And this is just to add a bit more level of complexity to everything. And then we merge those, right? And then I'm just packing them, transfer this attribute that I mentioned. They already have a name. Here I build some constraints. As you can see, it's pretty simple constraints just to keep those pieces together that I want. And then in Sim, I'm going to show you, I'm going to release them on specific frame when it works for me. And here I'm just using the active attribute to and relative size of the building, and then I'm just mapping the bottom ones basically to be not active. So it's these guys here. So they're not active because they're in the ground and they would stick more there, not fly around. So I'm gonna show you the result of the sim. So it looks like this. So the point is of this step is to have something something fast, something that you can iterate fast through it, and speed out like bunch of versions if you need. You can even wedge this out, and you know, but it's pretty quick to play with. The sim is pretty simple. So we just have this, what, 15 pieces, yeah, 15 points we can see here. So 15 pieces, I just have some drag, and this is, I have negative here, just to add some weight to everything. So it's basically going to be pulling down everything, and speed limit is just so that some pieces don't go too crazy. And time scale, this is something I was playing with mostly, and this value to get something that kind of feels okay to me. I wanted that slow motion feeling, but still you want to have that weight, right? And then I just have the character collision, and that's pretty much okay. Here we have glue constraints and soft constraints, and I'm gonna show you how it looks like if we don't break nothing. Actually, I'm gonna show you how it looks like with just the regular break. I'm just using distance. Let's see how that works. If you do that, we can see, yeah, it's pretty much okay. This is sim I liked, and what I wanted these pieces also to split, right? Like here, here, and here, right? So I'm just releasing those constraints, and here I'm using that piece ID attribute. I'm accessing it through the primitives, because each primitive is a constraint. Each primitive has 2 points. So we just check those 2 points and check which piece are they connecting to. And then I'm just here releasing them for this piece 3, 1, 4, 2, 5. So I'm just releasing them on specific frames as I found it works for me. And this is, yeah, I mean, usually this you can set up here more attributes, angle, and whatnot. But for me it was, because the sim is pretty simple, I just have 15 pieces. For me it was highly controllable like this. I just wanted those specific frames to break. So when we have that, I'm just going to show you the difference. As we can see now, we get here like really nice opening, we get here really nice opening, and there some stuff is going to be happening, this guy here. So it's just a way to make it more interesting, but I didn't want everything to break at once, right? I wanted just big chunks, super big ones, and then slowly we're getting opening of the half sizes of them. So that's our sim, right? So when we are happy with this sim, what are we gonna do? We're gonna, basically usually you would just cache, not as this, not like as a geometry, but you would cache it as points. So right, points. And what do we have here? We just have 15 points, so each point represents a piece, right? Each piece has a point in the middle, and these points have just information of the name, so which piece it belongs to. Orient is just rotation information, and pivot and position are just telling where it's, what's the position of the object, right? So, but in this case, we could use points directly, right? We could use that, but what I'm doing here, I'm adding one more layer, right, of art direction, let's say. So basically, I wanted some pieces to act a little bit differently, so I just went and you see this one, I just rotated, and if you can check, if you can see, I just selected that piece, and I'm just animating the rotation a bit, so just a bit more of control to add. And some pieces like this one I also rotated, then this one I moved it a bit down, this one I moved it a bit down to have a better feeling of gravity, of weight, and then these both I also put them a bit down because they were a bit hanging up there. I wanted still to have that weight. Okay, so now that we have that set up, right, as we want, now I'm gonna extract the points from that, and they're gonna give me transform and rotation, right? So yeah, basically same thing, just these are now moved as with this, right? Then we're just gonna save them, we're gonna reuse them. Basically this is gonna drive everything, and this is really useful technique. As you will see how it's used. So here we prepared the building, right? We give it some names. I just boolean everything, so it's kind of, I get rid of the intersections, right, if there's any. And here we're gonna do the fracture. So the fracture I'm gonna use also. So I'm gonna reuse these pieces, right? Because I want here to have small parts. So I'm gonna reuse these inside surfaces that we have from cuts, and they look like this, right? So here comes the padding part that I mentioned to you. As you can see, they're a bit bigger. So if your cutters are a bit smaller than your building, you're gonna have trouble. Your boolean fractures are not gonna be working well. So it's just, yeah, padding is for that, to just keep them yeah, bigger than the building. So how are we going to reuse this? So these are inside surfaces of each piece, so the new surfaces that the initial cut provided for us, right? Created. So we're just gonna clean them up so we don't have like double. As you can see, some of them here are doubles. So we're just gonna clean that up. So we fuse the points to make sure that all points are together, and then we just use this clean like this, and this now gives us one primitive for each. So that's pretty cool. So now we're gonna use this. I'm just gonna keep the building like this so we can see what's happening. So now I'm gonna obviously add some noise to this, and let's see how. So I'm gonna remesh to add some details. So here in this part you could push this more, but I mean, you know, for me that was not the point. I wanted to have gradually adding details. So for me this resolution was pretty good. And then I just copied. I use this copy num attribute so I can offset the noise that I'm going to apply through normals. And so yeah, so now as I mentioned, we have two copies, right, of each piece, and with different noise we get this. So basically it's creating this in between two big pieces, right? This area that's going to be there. And then I just copy that one more time. I do the same thing, remesh, and then again I have a noise applied, so that looks like this. So it looks weird like this, but you will see in a moment the result of this. Also I'm adding if you remember, we had these secondary fractures here, right? So those are these pieces, and I'm just gonna reuse those cuts also. Same thing. I'm just adding those cutters, and I'm adding some noise, and we're using them. I'm not gonna run this because it's pretty heavy, but you can run that once and that's it. You can cache it out. So this is how the result looks like. So this is our building, right? Okay, and this is the fracture. So as you can see, there is a lot of pieces, right? And the good thing about this is that I'm focusing my fractures where I already know that they're gonna happen, because usually you would just go, I mean, you would fracture the whole building, you would have 60, 70, 100,000 pieces, doesn't matter, and then you would use constraints to have these clusters, and that would sometimes work, sometimes it doesn't work. You have a lot of different constraints. So for me here it's pretty simple because I already know where the clusters are going to be, so I don't even fracture that. So basically I'm saving pieces, and if we check here, I just have 16,000 pieces. So that's not a lot. Like before, earlier, before I was using this technique, I used to have 60, 70,000. The sim is slow. It's slow to iterate. If you have nodes or whatever, it gets pretty complicated. So also here we could have used. This is something I'm gonna dive into later. I didn't have time, but we could also, instead of, I mean, I need to check would that work, but I assume I would find a way. So instead of pre-fracturing pieces, we could pre-fracture once, right? And then we could do dynamic fracture of the pieces in sim, depending on their collision on impact points, right? And then we could take those cutters and then try to feed that here. But let's see. For now it's like this. So basically we take the fracture, I do a bit of cleanup, so I clean up super small pieces, and I group the big ones, and I group the small ones. So let's say, so these are the without the big ones. These are just the big ones, right? And if we have small, so these are just the small ones, right? So now what we're gonna do? We're gonna prepare this for sim, right? So because we have, this is our high-res fracture, and so for solver to read this correctly, because bullet solver is basically going to create convex shapes around this, right? And so what we need to do, we need to do convex decomposition. That means it's going to take each of these pieces and create additional shapes to represent this geometry properly for the solver. And we just do this for the big pieces because they have these irregular shapes, right? And for the small pieces we don't need because they're already small and they're already kind of have concave shape, right? So now that we have those fractures, what are we gonna do? I'm just grouping some pieces at the top. This is just for some of my own stuff, some control. It's not necessary. Same thing here, cleaning up just some geometry if there's some bad primitives or whatever, just cleaning up, and giving some UVs. Then just packing stuff, transferring my groups because I'm gonna reuse them, promoting my groups to points so I can access it. And then comes the technique that I was telling you about, that how are we gonna transform, how are we gonna reuse this sim to transform the high-res geometry. So basically what we can do, we can just, if we check here, we have name, and that we have 15,000 names, which matches this number, right? So each piece has its name. If you check here, there's 15,000 pieces, and each one has its name, right? So what are we gonna do? If you remember, I also mentioned that these points that we extracted from the sim, they also have a name, right? They have 50 names, and this node, transform pieces, is gonna use that name attribute to know how to transform these pieces, right? So I'm transferring the names from different points. So I'm using each piece, and I just want to make sure I could transfer from these guys. Just use a big radius on attribute transfer. But this kind of gives a bit more precision, right? So what I have here is just, yeah, as you can see. So I filled each piece with points, and then I'm just giving them name, and then using that to transfer to these fractured pieces, right, of the building. So if you check here, now we have 50 names, right? But remember, we stored our original name because for the sim, we're going to use our original name, and for activation, because of the solver, otherwise if we run with these 50 names, it would error, it wouldn't be working well. So for now, we're just going to use these 50 names to transform. So as I said, now we get those points, and you can see here we have, right, 50 names, here we have 15 points. So, and we also need rest points here, same ones, just frozen in the first frame. So this is our sim, and if we go here, transform pieces, bam. So we have our stuff working, right? And this is with proxy big pieces. We also have on this side, I do same thing for the high res, fully high res. So we have that, right? And for example here, if this was a task, you could show this to your supervisor or lead, and just ask for direction, like this is first pass, right? Do you like the movement? Do you want this piece go there, that piece go there? And at this point it's pretty easy, right, to move around stuff with this technique, or even resimulate if you need, or add more constraints, different cuts, whatever you need. But it's pretty fast, so that's the point, right? You don't want to have super big sim and then you iterate, like, you know, super slow, and it changes every time. So this is more about being fast and having a stability, right? So having a reliable result, you know what's going to happen, like, so that's good. Okay, for activation, we're going to get rid of the big pieces because we're not going to activate them. Unpack, promote our name, and get rid of our store name, some old attributes, right, to avoid any confusion. Then we're just going to freeze it, right? Only keep the inside surfaces, right? And then just only keep the points in the end. So now we're gonna find the neighbor points that belong. So we're gonna store our name again, right? We're gonna store our original name. We're gonna use the old name, this one from the original guides, because we're gonna transform these points, right? First, we're gonna find the neighbor. So we're gonna find the closest point that doesn't belong to my piece, right? So if I go here and do this, and say random from attribute name, you see different colors are the name of the points, right? So we're gonna try to find point from different pieces, and here we do that, we find the neighbor. So we do that by just using near points function and using some distance. I used quite a bit distance, maybe I could have used lower just to be safe. And I use quite a lot of points because, yeah, some points are pretty far from the next piece. So just to be sure, it picks up that. Yeah, and it's okay. It runs this just on one frame because we are using the time shift. So it's okay. And then we're gonna set this variable -1x. We're gonna later override it when we find this is gonna be our neighboring point, right? Later, here we're gonna declare it. So we're gonna use for each to go through this array, right, through these 2000 points. So it's gonna take each element from these, from this array, and then it's going to check that point, and it's going to check for the name attribute right from that point, and then it's going to check if that name doesn't match the name of the point that I'm running on. Then it's going to set X as that point, right? And that's it. It's going to break. So if this is 0.5, it's not going to run 2000 points, just going to run a few of them. And then we declare this. So we're going to reuse it after we transform to activate. But first we're going to check for the distance. So we're going to check for the position of that point and then check for the distance. So for some points, the distance is going to be 0 or close to 0 because they're next to each other, but for some points it's going to be a bit bigger, and we're gonna play with that later. So we also declared that res distance, so we're gonna reuse it. Then we transform these points with these old points, if you remember them, and we get this, right? They're moving. That's it. So now we're gonna again check for the distance. I'm gonna show you. So now we again take first we set the old points as active 0, right? And then we're gonna check again for the position of X point, which is our neighbor, but now we're checking obviously on the transformed, and so the distance is different. The distance is gonna be different, right? It's gonna change over time. And then I'm just using this multiplier. Actually, you can even animate that to make it grow, which I did here. I'm just gonna show how it looks without it, so everything gets kind of activated, not at once, but yeah, close. But here I just ensure that it kind of grows out, so it's not everything is activated at once, right? So what are we gonna do? We're gonna measure the distance we just got here. So we're gonna measure that distance against the res distance. Plus, I'm just adding this small value because some of them, as I mentioned, are gonna be 0, right? So we don't want it to be 0 because then they would activate immediately as soon as some movement happen. So we're just adding this small value, so it's not 0, and then times this multiplier that I added here. And basically I didn't, this multiplier just animated. It goes from 3 to, yeah, 1, pretty much. You could also use speed, right? And then activate by speed. I didn't want to use that because it's a bit precise here, but you could use this also. Then I'm just setting color so I can visualize obviously what's happening, and then I'm just restoring my name, right? I'm setting the name attribute as my old name attribute, and that's it. That's it for the activation. So now also what can happen is that some points are going to get activated, and then because, for example, this piece, if you check, is going up, and then he starts again falling down. So some points get activated, deactivated. So just to ensure that that's, you know, keep at 1 active, we're just going to check for the previous frame, get these attributes active and start frame. Basically this is going to be 0, this is going to be also 0, right, or -1. So here if we're checking, so if at this frame active is equal 1 and previous frame active was 0, then it's triggered, right? So we're going to set the start frame as this current frame. Otherwise use the previous start frame. And why we do this, because we just want to make sure that it stays on this frame once it's set up, right? So it doesn't change if it again happens to active or deactivate. So that's it. Then we keep freeze this at the last frame, right? Why? Because now we have all of these start frames, right? Some of them are 0, that's normal. Some of them are not going to get activated, and see here it gets start to be activated. So that's good. And then we just get rid of all points that are not. If the frame is after before the start frame, then we just remove all of them. And that's it. We have our points, and you can see here it's kind of growing, right? So that's cool. And we can just also view that here in this view. Pretty cool. So that's it for the activation, right? Okay, so let's now go to this part of the stream. So here we have that fractured part, right? Just gonna remove this. Sorry. Okay, that's good. So we have transformed right pieces, and I'm just gonna restore names, right, to use so the sim can use correct names. Remove the restore name attribute, and then here I'm just setting piece ID if I need it. Not sure if I use it. Here I'm going to do some constraints I'm going to show you, but first to set up the attributes and activation. So we set up the active equals 0, animated equals 1, which means that at this point, if I would send this to sim, all pieces would be just following the transformation that we did, right? We just do this, but then we're gonna switch this to 1 and this to 0, right? And we're gonna switch this, so this node, this function is gonna check on input 1, and it's going to check point class, and so it's going to check each point. Is there a name attribute that matches my name attribute? If there is, so if it's not -1, and I'm not big piece, set the active to 1, animate it to 0. Now we could also use here speed, but basically because we have, for example, these two pieces or these two pieces that are moving and then later they get activated, it's not really working. But it could be if everything is activated at once, if it's just one big hit, you could use just this simple way. And then you don't even need this part. Like this whole part is not necessary at that point. Here I'm just grouping some static pieces that I wanted. Actually, they're not going to be static, they're just a piece. Not sure why my viewport is bugging. So we have static. It's not static, it's just pieces that I wanted to keep static until certain frames, so I activate them at this frame. And just to show you constraint, nothing crazy. So I'm just blasting the super small ones. I want them just to fall down. Don't care about them. And I'm just connecting pieces, right? And we do this at the frame 1 or frame 168. It doesn't matter, just first frame. Then I'm just scaling them down, and so this is important. So as you can see, constraints are still there, but if you don't have this, they get this. So for solver, it's a bit more stable when you have them as a scale 0 as 1 point. It's 2 points, but it's just there at the same position. So here I'm just using soft constraints. And position only. I didn't want to constrain the rotation. I want them to rotate freely, like if they're falling down on each other, rotating, whatnot. So that was just it. And then I'm setting here rest length because the solver is going to ask for this. So it's basically length. If I had this off, I would need to measure this, and then that would be our rest length. But because I'm zeroed out, we just set it at 0. And this prim ID attribute is just it's kind of convenient to use if you want to delete something in the solver during the time steps. If you use prim num, obviously time step is going to update, the bullet solver is going to update your prim num, so that might mess up your constraint order. But if you set this attribute, you can call it whatever. If it just matters that you set it up before, and then you can use random function based on this and just blast primitives later on. And I'm just blasting 80% of them, so I'm not even using everything because I don't want that much. I just want them to keep together, but not super tight, right? And here I just separated. So this I did afterwards, right? I noticed one piece, I wanted to pick it and just like to keep it like together, whatever, and to have some pin constraint there. So I'm just creating some tiny constraints, same thing, copying, and this one is same, it's just called pins. Okay, so let's jump into the sim now. So I can show you, first I'm going to show the result. Actually, let me show you the result. So this is the result of the sim. So we're just caching out the points from the sim, right? So it looks like that. And then when we transform these pieces, because we can just go like that, we transform them, it looks like this. So that's pretty cool. I liked the result. Let's just jump inside the .NET to show you how it works. Basically, we have here building, and I'm just overwriting active attribute because remember that's coming from here, and this is updating every frame. So we're just overriding that attribute with this value. Nothing crazy here, collision padding, almost default values. Here I'm just using some drag, a resistance with some weight, so just to pull them down. It's basically not gonna act like a force, like a gravity, but it's more as a resistance, right? It's like a target velocity. And here I just have time scale and constraint iterations are set to 1. This is gonna make my constraints a bit softer, easier to break and whatever. So time scale 0.8 and drag. This is some values I would play with just to get something that looks good to me, right? And here we have those soft constraints, use really low stiffness, and then pins with also low stiffness. And I'm breaking them. You can see here I'm just using distance for the non-pins constraint, and for the pins I'm just using the frame, right? So I blast them in the frame. So that's about it. We have collision objects, so that's this guy, and we have ground plane, so they don't fall down, even that's okay. And gravity is pretty much regular. I'm just gonna play the sim so you can see that this still, how much pieces we have? 15,000. Okay, so I'm just gonna run it. Okay, so as you can see, it took me around 2 minutes to cache this, right? So it's pretty fast, I would say. And it's it's doing what we expect it to do, right? Everything is acting as we want. Nice stuff. Okay, so let's go to the caching. So as you can see, I'm just getting directly the points with those attributes, and then we transform our pieces. As you can see, there's a lot of stuff coming out. It looks pretty okay to me. So now we're just gonna we're gonna get rid of these proxy pieces, right? We're gonna just keep the high res ones, right? The high res ones, and then from we're gonna use the proxy, the big chunks. We're gonna use them. We don't need to simulate them because we're just transforming them. So we're just gonna use them from here. So this is our RBD sim, right? This is our base sim, and yeah, that's pretty okay to me. I like the sim. So what do we do next? So basically, what's gonna happen? First of all, I need to upres this. I need to add small parts. You could do that by just using the breeze source and just emitting some points there. But for me, I like more when I see a piece separating and falling down. It gives a bit more realism, and yeah, if you just have points emitting, it's kind of visible that it's just emitting. It's, you know, especially if they're bigger a bit, if you have one point that ends up being bigger, or you instance something, you can see that it's just emitting. I really wanted to see stuff falling apart from these edges everywhere, like here and there. Also, second thing, usually when you have a sim like that, there's a lot of pieces and whatever, there's a lot of stuff happening. Obviously, you're going to have a few pieces that you're not happy with, and you can have your 95% of your sim, you feel good about it, but then some part of the sim you don't really like, and we're going to address that too. So just a second pass to polish the sim, right? So how we do that? So first, let's find those pieces. So basically, what I do, I just isolate the pieces that I don't like, and for me, those are basically these pieces. So for some of them, I didn't like the shape. For some of them, I didn't like how they move. Some of them, I just wanted to have more fracture or whatever. So here, I just remove. I keep all pieces except those, and basically, this is going to be my collision layer for that sim. And this sim is going to also be pretty fast because there's not a lot of pieces. So what are we going to do? You remember we have points that drive this sim, right? Those are these points. So each one of these pieces has a point from here that tells us how it's going to move. So what are we going to do? We're going to do the same thing. We're going to take these pieces, we're going to freeze them, we're going to fracture them, and then we're going to transfer them with those points because we're going to have the old name. We're going to remember the name of the parent piece and then just use that parent name to transform our pieces, and then we're going to send that to sim and activate them. So let's do that. So here I just fractured them, and I'm going to show you the result of the fracture. So basically they were all one piece, remember, and now we have like a bit more fracture here, right? So that looks pretty okay to me. That's what I wanted. I wanted to break them in smaller parts with some grit in between and yeah, stuff like that. So now we take that, just fix some UV, some group, and then same thing. I'm gonna use the old. First I store name, my original name, my new name. So we have 2,500 pieces almost. So we store that name, and we use the old name, which is the name of the original piece, right? And then I'm using, as you can see here, these are our sim points. And then we're just going to transform them. So at this stage, we have pretty much the same thing we had here, right? It's just these new pieces are fractured now, right? So before they were one piece, now it's fractured. So now we restore names, and then we're going to do activation. We're going to use those pieces, and the same thing. We're going to just run the neighbor points. We're going to find when it's separated from its neighboring piece. But now we're not going to use those 15 pieces. Now we can use each piece, right? That looks like that. We activate pieces, and here, as you can see, we don't even have any constraints because I already know I just want this to fall down. I'm running here. It's running solver. So here it's same type, pretty much same type of activation. We set them as a non-active, pretty much copied the same thing from here. And then I'm just using for these smaller pieces. I wanted to have to add them some velocity, so I'm gonna treat them as a separate object and just add some velocities and yeah, blast them around. So as you can see that here, let me just see. Okay, I need to let this run. Okay, so these are the pieces. If I can show you here, we have this, and we have some velocities right on them. So the solver is just gonna blast them around. Let's go in sim. So in sim we have 3 parts. So we have collisions. So as I told you, it's just the pieces that are leftovers minus the super small pieces because I didn't want to collide with them, just to make my stuff faster. Here we have, so these are the ones I told you we're gonna inherit some velocities and make them explode, and then these are the other pieces that's left. And same thing, I'm just using some drag here, speed limit. Here it's pretty much everything is default. And yeah, worth mentioning, these things like time scale and drag, I just do that by the feeling, right? Sometimes, you know, it doesn't make sense, but it looks good, so I just use it. I don't care. For me, it's important that it looks good, not that it's mathematically correct. So yeah, just, you know, play by your feeling and see what works for you. And as you can see here, I don't even have constraints, no collisions, nothing. I'm just activating those pieces. So I'm going to show you the results of this sim, right? Here I'm just caching the points because it's faster, so you just cache these. They look like that, and we can check here the difference, right? So we had, let me just put here, switch. Okay, so we have this, and we have what we started with. So that was this. So if you check now, the original was this, right? Not super interesting. I mean, it's isolated. There's a lot of stuff happening. This is isolated. So this versus this, right? So we get a lot more small pieces. It's a lot more interesting, right? Like there's a lot of stuff happening there. So that's good for this part. So we're gonna merge that. Basically, these pieces, we're gonna remove them from this sim. We do that here. So here I'm removing some pieces. The ones I'm gonna do the secondary stuff on them, Upres, and removing the isolated one, and we get this. So these are our big pieces and super small one. On them we're not gonna do nothing for now. So this thing like that. So let's go for these pieces and this sim, as I said, we're gonna use the wedging. So you remember this attribute that I created, guide piece ID. So now we're just using the wedge num, and wedge num basically comes from our topnet, which is here, and I just have this wedge, for example, 15, and I'm just connecting that to a bunch of different simulations. And I have different wedges. So for example, for dust, I used 6. For glass, I used 5. Yeah, but here we had 15 because we have 15 big pieces. So what are we doing basically here? So we're gonna take each of the big pieces, right? We're gonna take every big piece, and we're gonna upres it. And that means we're gonna add smaller stuff inside. So same thing as here. Basically literally copy of this. We're gonna freeze this in a rest position, unpack, and we're just gonna keep the medium-sized pieces. So I'm getting rid of super small ones and big ones because I don't wanna upres those. So the bigger chunk and these super small ones, we don't wanna upres them for now. So we have these middle sizes, right? So we set the old name. We set the old name to remember the name of each piece, right? To have it. And then we're going to fracture. And this time I'm going to fracture. I'm just going to scatter some points on the inside surfaces. Probably there could be another way. I was thinking to reuse actually the inside surfaces that are already and add noise. But for now I just use this and it kind of works okay for me. It doesn't matter. So I'm scattering some points on inside. So we're taking for each piece. We're just taking those inside surfaces, and then we're going to scatter some points there. And the number of points we're going to scatter is it's just coming here from I just derive it from the area, right? So we have area of each piece, how big each piece is, and then I'm just mapping that to know. So bigger piece is going to have more points, smaller piece is going to have less points. And so here I'm using just ×1. But I'm going to show you, the more we push this, the more we're going to get. And honestly, I could even push it a lot more. I didn't want, it was okay for me, but for my next stuff I'm going to do like this, I'm definitely going to try even more. So let's see what this gives us. So here I just group in, which means I'm going to show you what is that. So we have our building, right? But I don't want to upres everything because this here in the middle we're not gonna see. It's covered with smoke and it's gonna be covered with big pieces and everything. So I don't wanna waste my memory on that part that we're not gonna see. Instead, I just wanna fully focus on this part that we're gonna see actually, right? Especially the one that's gonna be in front of us. Behind is not even that important, but yeah, still it's okay. So I'm just grouping those pieces. I'm scaling that. You see I'm using bound and just minusing some, padding it inside, and I'm grouping. If there is any point that's inside, we're just gonna blast it, right? We're not gonna do Upres there. And then yeah, blasting those points. Not all of them, I keep some, right? And randomize normals. This is just when I instance my cutters, they're just gonna be differently oriented, right? And piece scale, so we get something like just those pieces, and we add noise. So this gives us some geometry that we're gonna use as cutters, right? And works pretty okay. So for this piece, we're gonna get something like that, right? So when this piece starts moving in our original sim, and when this part separate, we're gonna get a lot of stuff in between, right, happening. And this is gonna be for each piece, right? So it's gonna be a lot of pieces, but it's gonna look good. It's worth it for sure. I'm just doing here final cleanup. So I measure per piece. I measure the area so we can have the groups. I remove the super small one and I just group the big one. And here I'm using the this big one here because I'm not gonna activate this guy. I'm not gonna activate it. We're just gonna activate those. This one is already simulated from our previous sim, right? And I'm just gonna activate the small one. So we group that guy. So we keep it as a group. We will use it in activation. And just clean up, nothing crazy. So here now I'm just gonna show you how the uprest fracture looks like. So let me show you that. Okay, so we have the fracture done, and basically it's this. And before that we had this. So as you can see, we get a lot of stuff in between, right? And remember I told you can push this even further, right? So what if instead here of using 1, I push it more? So let's say I put 5. And obviously this is going to give us a lot more cutters and a lot more geometry around the edges, which in the end is going to look even better. But for my stuff, I did not feel the need that I need to push it. So let's see how that looks like. You can see it's loading a bit more, but that's because it's going to have a lot more pieces. So yeah, as you can see now, the whole edges are pretty much shattered in smaller parts, and we can check that. Yeah, you can see you get a lot of stuff. And if you check that just a bit more like this. So this is the super, a lot of pieces. This is the original one. So yeah, you can see there's a lot. And this is just one piece. Obviously we're gonna have 15 pieces. So that's why with this you can be a bit more, don't need to go too crazy, but yeah, you can push it. As I said, in some of my coming projects, I'm probably gonna see to push it even more, right? But this was enough for me for this thing. So basically, what are we gonna do now? Same thing. We just packing. We transferring that old name attribute that says each small piece now which big piece it belongs to. We're transferring that group because we're gonna use group to tell which piece is not gonna get activated, and then we just use that old name. So see, we have 177 old name. These are initial pieces, and then we have old name. Almost 2000. We transfer the pieces. So this was our sim, and pretty much same thing. I restore name, then activation part. We already went through this. I'm not gonna go here. Pretty much same thing. Just let me see here if I'm using the same activation, or there is something else happening. I'm pretty sure it's same. Yeah, just checking for the point. If there's a point there, activate my piece. Pretty much same copy thing. And the sim, let me first show you results so we can check that. It's not loaded from disk. I need to use this one. Here, so I'm gonna load all of those pieces. As I showed you, we have 0 to 14, which is 15 pieces, right? And I can load just one to show you. And let's say it's this one or whatever, this one, because we worked on it. So let's check the difference here. So Upres versus just our base sim, right? So this is Upres, and this is our sim. I mean, we're just missing the big piece, which I can bring in, but yeah, no need. Like you can already see the difference, right? So there's a lot of this smaller stuff, and this smaller stuff actually gives the scale, the sense of the scale, right? That it's massive, right? So that's it. I'm just gonna keep here. I'm loading all the pieces, 14, 15 of them. And if you check that, how that looks like, yeah, you can see there's a lot of stuff happening. So that's pretty good. I'm just gonna show you the sim quickly, even though the sim is pretty much copy of the other sim. So we have collision building and the debris. So we have all the pieces that don't belong to the, as you can see, all those pieces that we uppressed, we're removing them, and everything else is using as collision, and these are our pieces, right? So we have correct collisions everywhere. Drag here, I'm just using, I wanted to, because here we have a lot of smaller, like some pieces are going to be super small, right? So I wanted to have drag on them, and that's why I'm ignoring mass. I wanted those super small pieces to not fall down, to kind of keep hanging in the air. Like basically they're going to fall down, but super slow, right? And then here we went through that. Here the time scale, already explained that. That's it. We don't even have the collision with the guy. We don't need it for this part. And then gravity, pretty much everything default. And yeah, I showed you the result of that. So now when I'm also blasting those isolated pieces that we took. I'm just blasting them from this sim because we don't want them here also, right? We don't want double pieces. So I'm blasting them. I'm promoting this attribute guide piece ID, and just, yeah, use it. We're gonna reuse that later on. So now basically what we have, as you remember, we have here all the pieces that we did not upres. So the big ones and super small ones. We have those that we isolated, that we didn't like, and we have the pieces that we just upres. So that's our whole thing, right? So now we merge everything. We merge all of that. So this is our RBD sim basically, and we're gonna add some more stuff, but for now this is good enough, and I'm gonna show you where we're gonna add. So this is pretty good. If we go here, there's a lot of stuff, and remember, this is just RBD part. We're still gonna add smaller debris coming from that, smoke, so it's gonna be full. And that's what we want. Actually, we want to be to have that massive look, like massive material coming down. So now, I still wasn't super happy when I rendered everything, and I wanted more stuff coming from these edges, and I didn't like these shapes, and kind of felt weird. And same for this piece. The other pieces were good because they were covered and they had some nice movement, but these two were kind of, first of all, they were in the middle of the screen, so taking a lot of attention, and yeah, so I just wanted to add some more stuff to them. So I'm gonna show you how we do that. So after this is our final, and now we're gonna take the big pieces and do some stuff there. Okay, so let's see how do we do with the big pieces. So basically pretty much it's same technique. It's like upresing the previous step that we did. So I'm just gonna do it for the big pieces, and not for all the big pieces, as I mentioned, just these two. So I'm gonna show you, basically isolate this piece using that ID, and just blasting some pieces that I don't want, and pretty much same thing, unpacking, setting the old name, and we have it at the rest position. And here I'm just using some fracture, right? Pretty much same thing. Yeah, here I use the bound. I usually never fracture directly geometry. I always create a bound around, create my cutters, and then use those cutters to cut up my geometry. And the result is this. So I'm just going to show you here. So this is the result of the fracture. As you can see, we have a lot of pieces now, and basically what we're gonna do, we're gonna kill this on the edge, like not kill, we're just gonna activate them over time, basically. And yeah, could have showed you this one actually, sorry. So that's it. This is our fracture. Here, what do we do? This is for small instances. I'm gonna use to instance debris points. Just blasting a few pieces from here, right? And so I pick those small pieces, and I say, okay, I'm gonna instance these pieces on my debris later, and I'm just using the match size to have them on a normalized scale, so now they're all the same size. So when I use piece scale, they're going to be the correct size, right? If I didn't use that, each piece is different, then your piece scale doesn't really work as you would expect. But anyway, so here we have the fractures, and then we're gonna same store name and use the old name, and we're gonna transform stuff. So if you go here, it's fractured, right? So we restore name. We need the original name for the sim, the name we stored. Activation 0, and trail is just for the last frame. It's not working. And here I'm just adding some random rotation to the pieces just to have some stuff. And then for constraints, I think here we don't need this. I think it goes this. I think this mistake. So constraints, nothing crazy. Just to get some structure inside to keep holding everything. And I'm gonna show you the result of this sim. So we go from basically, and this is the piece that actually gets hit by the fist, so I wanted to have some extra stuff there. So this is the difference. So before we just had, oh no, sorry, before we just had it as a one piece, right? And now I'm adding, right, adding stuff. And this is the beauty of this like technique with this transform stuff. You can transform it and just subfracture and transform again. And if you don't like one piece, just resimulate it, you know, just take that piece, fracture it if you want, resimulate, add velocities, do whatever you want. Basically you have the whole control. It's just about the organizing, right? Not doing everything at once, you're not expecting one sim to give you like your final result, but just dividing and conquering stuff, because that's the way how to achieve these results. So this is our Upres sim, and then of course we just do secondaries just for this guy, and I'm going to show you later how we do secondaries, debris and all of that, but here I'm just going to show you quickly. So I generate the source for debris, and then here we have some debris points that I simulate, and when we add this together, right, I'm just going to show you quickly. So we have this guy and we have this guy, right? So you can see we get a lot of stuff there happening. Looks pretty cool to me. Yeah, it's gonna be messy, which is good, right? We want that chaos. And also we have dust, right? I'm gonna go into dust later. Here I'm just gonna show you. So I have 3 different, I think, layers of dust here. I have this one that's kind of like a pointy, spiky source, right? So I have that one, this one. This one is from the big chunk. So this one is a bit more like bigger, dense, you know, bigger shapes. And then we have one here that's kind of low density from the pieces flying around. So yeah, when we combine all of this, you get a really nice realistic results, because it's different sims with different values, and I'm gonna go into that later. But yeah, this is the method. And then the other piece that I did, it's this guy. So same thing. I'm not gonna go into this now. It's pretty much the same thing as all other ones. I'm just gonna show you the results basically. So we had this. This is our initial piece. It goes like that. So here I wanted pieces to have like leaving a trail basically, yeah, because it's chunk, and I just wanted it to keep separating the whole time, right? So we have that, and then the difference is this, right? So as you can see, this adds a lot, and this is just a small part, right? Like you have so many things happening that this is pretty much enough of details. As you can see here, we kind of these pieces are separated, but it's still kind of holding together because there's rebars inside and whatever. So we're just simulating that effect, right? So that looked pretty cool. So that was it for that part. We also had some extra geometry. So these are my secondaries. I'm gonna go into that later. So that's debris and the dust. I'm gonna load that now. It's pretty heavy. But here I'm just gonna show you. Okay, so we have that, right? We have the big building, and it's here. So at one point I was like, okay, like I really don't like there's no roof. Like it's pretty simple, right? It's just a cube. It doesn't have any details, nothing. So I wanted to add some geometry, right, to make it a bit more. And usually you would not have this step you would get the finished model, obviously. But if you're working at home alone or R&D like me, it's like this technique is very useful because you can keep adding and infinitely. And also, at some point, you will have this case, like when you're working in a studio, because sometimes they're going to change geometry, they're just going to add something, and you don't want to resimulate everything. They just want to say, okay, can you just take this? We added some billboard here. Can you add it? Yeah, sure, I can add it. So you reuse your sim, you transform it, you fracture it, you activate it, and that's it. So basically here, I wanted to add something on the roof, right? So I'm going to show you how we did that. This is some chunks there. Okay, roof here. So this is our roof. So how we do the roof, pretty much same thing, but this one is a bit different. So for the roof, because it's so small and whatever, and I wanted to have just like some bigger pieces with details. So I fractured kind of everything. I'm going to show you. So it's pretty much, this is my idea, to have these clusters, right? To have stuff like that, right? And that's why I fractured everything in, like, I mean, you can use this technique also. But as you can see, this generates like a bunch of pieces, like a lot of them. And then you just create clusters. You say this is one cluster, whatever. And then, yeah, you add clusters with this node, right? So that's what I did. I just, yeah, didn't want to go too deep into that. This is how the fracture without clustering looks like. So you can imagine if I did the whole building like this, and to have those irregular shapes and whatnot, more interesting stuff, that would be a lot of pieces. Like just for this roof, we already have, where's my name? Yeah, 10,000 pieces. But if that's just a small part, right? Like if I had the whole thing, that would easily be above 100,000 pieces, which would be super heavy, right? Obviously. So what do? I just assemble them. Store name, we use these sim points, and we just transfer the name right to these guys. And yeah, I use point jitter because I wanted to have some irregularity. I wanted to add some chaos. So this point jitter just move points around, and then I'm just copying to original position, right? And here on this side, this is different type of geometry that I did. This one I did not use, but I'm gonna show you. It looked pretty cool. I'm not even sure why I didn't render this. So we transfer again also the name for this one, and then we transform everything. And so I'm gonna show you how this looks like. So basically you don't even need to simulate this because the pieces are so small that it already looks like simulated, right? Like this is no sim. I'm just using the sim points. And if you check with the original sim, if you go here and check with the original, like all of these pieces are sticking to already some piece that's already simulated. Like for example, this guy, you see he has his place, he's sticking to simulate piece. So basically we could let it like this, right? Like it would perfectly work like that. So this is how our roof looks like. So basically what I just wanted some more these pieces like falling down or whatever. So I grouped my parts, right? Like I took this, I took the last frame, I made the groups for all three, and then just grouped some pieces that I wanted to separate, right? So the final sim looks like that. I'm just gonna show you here, that. So we get this in between, right? And we get stuff hanging and whatnot. So that's pretty much okay. That's pretty much okay. Obviously we're gonna add some debris and everything to that, so we can see how that looks like here. I'm doing debris and just blasting some pieces. So if you check, it's a bit heavy because there's a lot of pieces, but you can see what's happening. So basically, even though you can see these are pretty low res, like they're just for no fracture, right? But when it's combined with this mess, and with these pieces that have some detail there, right? We're gonna see it like this. So they already have some detail, and when we add some stuff around and dust, it's okay. It's pretty much okay. So basically, you need always to make a decision, right? Is this something that's super high visible? Am I gonna be like close to this and then see that this piece is really small? But like from my camera, it was pretty much like, right? Like it's a waste of memory, right? Taking into account that it's gonna be covered with dust, right? So that's our roof. I also do some dust for that roof, pretty much. Yeah. So we have this dust sim. I'm gonna go into that later. Just gonna show. Okay, so there is one more RBD part that I just wanted to show that I added. So it's the character stuff. So if you check here, actually let's look at it like here. Yeah, let's check his sim, and then let's show character. As you can see, like his fist is pretty like empty. There's not much stuff. Even though there's something on top, there's not much. I wanted to add more. So for that, I just built some geometry, and I'm gonna show you what I did. So first, I just took the character, right? And here I'm just creating collider just to have proper collision. I'm using the same technique, convex decomposition, and then just deforming the packed points. So we get that, right? And on this side, I'm just basically idea was to create like just to create a geometry points around it and instance some debris points on it. So that's what I did. So I have this just volume, and then we scatter some points inside. It doesn't matter because this is just first frame. We're not gonna see it, but you will see how it looks like. And then I'm just instancing on this side. I just blasted a few pieces from the original fracture, right? And then I'm just copying them around and just simulating with this. I can show you one of these sims. So this one I even took this wall, so it looks something like that, right? So yeah, you can see the idea. I was just adding more geometry to have it around there. And if you check all of these sims, pretty much this is like, yeah, I'm just like here you can see instancing some points. Same here. They don't even have velocity. They don't have nothing. It's just driven by collision, right? And then when we merge all of that, we get this. It looks weird, right? But if you remember, this is going to be behind the building, and we're going to see it from this part, right, when it's coming out. And that looks like that. So if I go there, it's pretty cool. You have a lot of stuff, a lot of rocks, so there's a lot of mass, right? And if you check that, how that looks like here, so it's going to be like that, right? And the stuff on top with the dust is going to be good enough, right? So, and then yeah, I also did some dust from these pieces. Obviously, I can show you that later. Just some dust from them. So we have some dust around his fist also, and yeah, also vectored some points around. So that looks pretty cool, even though it's not that visible. Like, I mean, if you're looking for details, you're gonna see it, but because it's far behind a lot of stuff, it's not super visible. So that was it for RBD. Basically, yeah, I'm just gonna show this. So basically now we merge everything together. So here we had that one big piece, right? Remember we did that. We have this big piece. We also did that. We have this. We didn't use this. This is something I didn't use. Could have used it. Didn't use it in the end. And then here we have a roof, right? Also. And the main part, we're just blasting these two pieces, right? These two. And that looks like this. And when we merge all of that, we get our final RBD sim, right? So that looks like that. So I'm just gonna enable here that we can see a bit better. Okay, like that, and I'm gonna remove the guy. And this is without the character fist stuff. It's just this, so we can see how that looks like now all together, right? Yeah, pretty cool. Yeah, there's a lot of cool stuff happening, breaking, and yeah, remember we're gonna have debris coming from this, like small dust coming from all of these cracks, so it's gonna fill up everything. But I really like the shape of these fractures. It's very irregular, chaotic. Yeah, pretty cool. So that's it for the RBD part. In next part, I'm just gonna show you the secondaries, right? The dust, the debris, and then in last part, I'm gonna show you how to render it all together. In this part, I'm going to show you the secondaries. So that's the debris, and we're going to take a look at the dust layers also here. So for the debris, I basically just take our final building pieces. It's going to load a bit. So we take that, we take our sim, and nothing too crazy. I'm just going to unpack it. just freeze first frame, not freeze first frame, but clamp to first frame. Calculate velocities again, get rid of some attributes that I don't need, clean up groups, and then send everything to the debris source. Nothing too crazy here. And then just copy velocity there, so it doesn't get lost inside. And then we get this, right? This is our source. Then I keep this attribute guide piece ID, right? So we're gonna do this per each of these big chunks, right? Again, I'm just cleaning up some attributes. Here, multiplying velocity. Here, I'm just adding rest attribute if I need it for later use. Here, I'm just randomizing some p-scale, so we have different. We can visualize this like that. Yeah, actually, it's some disks, so we can visualize like this. So we just have some diversity there. And for the last, I'm just adding mass, initializing some life attribute because we have age, and then just scaling by that attribute and some random, so we get less of them. I'm gonna go into the sim just to show you a result. So here I'm also using the wedges. So I don't know if I showed this, but here you can just add this /veg num with these backticks, and that's gonna create you folder like this veg0. So in tops, when you run that, it's gonna cache out. And then to load that, you can use file merge and use this slice, and then replace this plug slice there, and that's gonna load all your. So this is all our stuff, and I can show you how this looks like with our sim here. So we get something like this. So that's pretty cool. And when we add the dust, that's pretty much enough details. As we can see, there's really a lot. And we could also run more write points, but I didn't want to have too many. Also, there is one more debris layer that I forgot to talk about. So here, when I isolated these big chunks, I wanted one particle just from the edge coming, and I picked a few pieces here, these guys, like these guys, and just emitting from some edges that I wanted to have more stuff when I rendered. I saw that, oh, actually it's a disk stream, so we keep these pieces, keep inside surfaces. Here I'm just time shifting, creating a mask so we don't have everywhere. Adding rest attribute, interpolate, and because I'm just gonna have constant emission from these edges, so that works for me. Then just trailing, blurring some positions to have some like clumped parts of source, and here I'm just multiplying the speed and adding some noise to the velocity. And inside, let's go inside of the sim. So just sourcing all points, some velocity, negative. Here I'm adding some drag and some noise, so nothing too crazy, and we have collision, right? And that's it. I think time scale is a bit down, just to make them a bit lighter. So that's it. I think it's similar here in this sim, so I didn't show you this. Yeah, okay, it's this one, yeah. So this one is similar, velocity, adding some drag, and here I'm using mass just to have the heavier one fall down faster and the smaller one stay in the air. And that same thing, collision, and that's a gravity. Time scale 1 here, that's it, and caching that out. So that's our debris. Actually, maybe it's good to show it like, oh, sorry. These guys, I didn't show you the cache. So the cache looks like this. So as you can see, these are just from these edges and constant kind of emission. And they're a bit big in p-scale, but later I update that. And we can add these ones also just to see how it all works together. These guys. So yeah, we get something like that. So yeah, already looks kind of massive, right? That's the point. So that's the debris part. The next part would be dust. So I just use these points among others to create some sources for my dust layers. I'm going to show you that. So we take, still I'm doing, also I'm going to do dust per wedge, right? Just to simplify things for me, make things faster. Here I'm using two sources. Let's go one and then I'm going to show you the other one. It's classic here, nothing crazy. So classic approach for the sourcing some smoke from the points. I'm just trailing them, preserve original, using ID attribute to connect them, so we have something like that, right? Then resampling to get more points in the middle, basically. And then just using curve view to map the scale and density, temperature, whatever. So yeah, here I'm using p-scale, and I'll show you how it looks like. And adding some noise also with curve view. Yeah, see, I use curve view here. And then here, I'm just creating some density, temperature, and alpha for color. I'm not sure I used color in the end. And then just updating a bit velocities. Let me show you like this. So yeah, just adding some noise on the velocity so it's not straight. Break it up a bit. And p-scale, multiply final, so we get something like that. So that's one of our dust sources. The other one I think is, let me see what we get here. Okay. The other one is also debris points. I know this one was actually from debris source. So it was just from the source points of debris, actually sourcing from the same points as these ones. And this part I'm using actually the particles. And same thing, trailing, resampling, adding some noise, pretty much same stream copied here, so we get that. So our dust layer, let's just see how this looks like. Yeah, you see this one is a bit thicker, and this one gives me a bit of those spiky sources, right? Spiky smoke. And here I'm just killing if anything goes down and creating a volume from that. Let's see how the volume looks like. So that's our volume source. As you can see, it's not too thick. Like you can play with this obviously. If I add more, if I add more, you can get something like that. But yeah, things to play with. And here I'm just removing color because in the end I had so many layers. I was just doing it by shader. It's okay to speed up our sims. And I'm going to show you the sim. I'm just going to load one layer just to show you how it looks like. 0. Let's see. That's that one. Let's try to find 1, 2, 3, 4. Okay, let's try this one. Might be the one we were looking at. No. 3, 2, 1. 1. Okay, so the dust is going to look like that. Right, pretty cool. And when we add our building, we get something like this. So yeah, that's gonna look pretty cool. And we do this for all of these pieces. I'm just gonna return here custom range 0. I think it was 14. I'm just gonna show you a few frames. It's pretty heavy, right? I'm rendering as a pack this primitive to speed things up, but this is the whole thing. I'm just gonna remove that. So get something like that. Yeah. So that's our dust from that layer, from the debris and these tiny points that are emitting. Then I also have one another, just procedural. It's not even a sim, just one layer. I'm using also points from the debris, and it's just actually for this guy. And I'm just making thin, really thin. And because those are debris points, right, they're already simulated, I'm just adding here some noises and everything just to get, I mean, I think I need to texture, and then maybe to show you like that. Yeah, when we render it's a bit more visible, but it's actually a really tiny source. I'm just gonna show you. Yeah, we get those tiny lines. So just a small layer to fill in there, just for this piece. I felt it was a bit needed. Then the other dust layers, I'm gonna show you that. So in this one, let's first see what's happening here. Coverage. Here I'm just using. You see, I had color, but in the end I didn't use it because it was a bit too much. But yeah, you can with color you can definitely add more details even. You know. Well, I'm just blasting here the color just so we can see this. And here I'm just using actually the one piece. I think I did the sims and then I like just one piece, and sometimes I do that. One piece is good. I like that stuff that's happening there. I'm just gonna keep that. but you can see it's okay sim. Pretty good for the scale we're using from here. It's pretty good. Let's see how many millions. 4 millions, not that heavy, right? Pretty good. And then in this one I'm using this. So here I think I divided in 5 parts. Let's see what's happening there. We're gonna unpack this. It's a bit heavy. Because we read the last frame. This one, as you can see, this is that layer of these streaky sources, like rockets, almost like looking like from fast objects. So yeah, I think here I'm just taking, let's see what's happening here. Final pieces of the building, and then I'm just keeping this upper part. Basically that's the only thing I see. It's falling down, and I'm creating here ID just so I can again do this per piece. Guide piece ID. Okay. Copying ID to the point to these points. I'm not sure why I didn't here just use guide piece ID. Because it was 14 of them. Okay, so I just needed to solve again to create a new attribute. Okay. Okay, we keep that. Then we just remove the big one. We keep these small chunks flying around. I'm gonna use that, and then pretty much same thing. I'm just gonna emit from the inside parts. Time shift scatter ID, and then same thing copied there with the resample. All of this pretty much same thing. Just here I'm sometimes, yeah, you add different things. This one is replicating, probably to have a bit more points, to have a chunkier, thicker look of smoke. So we get something like that. Yeah, just to have a bit more dense. Here we cannot really see it, but when we do a sim, it's visible. And just to show you the sim, so this is my resolution, setting up bounds. Here I'm just using density, temperature, and velocity, really small value. From the fields, I'm just dissipating and calculating speed. As you can see, dissipation is quite high for these pieces. And then shaping, I'm just have negative buoyancy because it will be heavy dust, right? And then I'm adding some wind here on this way, and some disturbance using speed, and turbulence using density. And that's pretty much it. We get what I showed you before, this one. So that's that. So that one we can also, just to show, I'm just gonna put this back just to speed up things. Not much of a difference. So just to show you, let's merge it with this, see how it looks like. Yeah, you can see this one really adds these spiky parts, right? Let me show you from different angle. Like that. And then we have here, we have this kind of dust, which is just dust that would be falling from everything down, just like from all the surfaces outside. And I call them airfield because first I wanted just to have some airfield to advect some particles, but in the end some of them actually were good. I'm not sure if I'm rendering. This one I just used as airfield, I think, if I was advecting something. But this one was my render dust, I think, and it's pretty low res. I think I even did this whole sim at once. Yeah, this one. So you can see it's just emitting from everywhere dust that's just falling down because it's heavy. And I think these layers turned out pretty good. Like here, all of that stuff was pretty good. Yeah, it was looking cool. And when you mix all of these layers, you kind of get that cool effect, right? You get different styles. And then here I have, just for the roof, I think also layers. 2 layers. Sometimes I do some versions and the other one is good. Or I want to apply some masking here using some points. Usually you can do that also with the volume wrangle. So just this is probably the most thing that I use every day. I'm just, you know, getting the closest point, getting its position, finding out the distance, and then just multiplying stuff, masking it by distance to this to that, and that's it. So here, for example, we're masking, yeah, we're just keeping everything that's close, not even stuff that went outside, just inside, even though there's some cool stuff, but I guess it didn't work for me. So just stuff that was inside. I think same here, I'm using that same. I didn't want too much. This guy also. Some masking. Like if I remove this, yeah, it's very heavy and it has these. But if I just keep that, so it's gets pretty thinner. Yeah. So that's the dust. And the last layer, I know that's this one. And pretty much I'm going to show you how I do this. So I just create a bound for the whole thing. And here I'm using for each piece. But I think I'm just keeping the big ones, trailing. That's for the collision. And here, yeah, I'm just scattering points everywhere on these big pieces and just adding density there, temperature and velocity. And in the sim, nothing too crazy. Time scale lower, voxel size. See, voxel size is pretty big because initially I just planned this to have some for advection, but in the end I just used it as a rental layer. So I'm just limiting maximum size here because I didn't want the smoke to go crazy around because it's already big. Collision setting up, same sourcing pretty much, and dissipation. Again, since it's heavy dust, it goes down. Same wind there. Some disturbance. Again, based on the speed, and some turbulence, and that's it. Pretty much similar here, I would say. I have some substeps extra. Same setting up bounds. Pretty much, yeah, copied. A bit different setup here, maybe. And that's it. And yeah, here I always remove these two because we don't need them, and these two. And usually I do this. I forgot to do it here, so this should be okay also to save some memory on the velocity. And that's it. That's it for the dust. Later I'm going to show you how we combine all of these layers to get the final look with the dust and debris. It looks pretty good. So that's it. That's it for our secondaries. In the last part, we're going to go into rendering, and I'm going to show you how all of this looks together.